You ever watch a drone just slice through the sky and wonder, what is that invisible thread connecting it to the pilot on the ground? It's like magic, right? A simple nudge of a joystick and this complex machine just soars. But what's really going on in that empty space between the controller and the drone?
Okay, so let's really get into it. We're going to pull back the curtain on that invisible connection. Because how that drone gets its instructions, how it stays so perfectly stable, and how it sends back a live picture, well, that is a really cool story about radio signals, some seriously powerful processors, and just some brilliant engineering. So the first thing you got to know is that it's not just one single link. Think of it less like a single phone call and more like three super critical conversations happening all at the same time, and each one has its own very specific job.
See, for a flight to even happen, you've got these three distinct data links just constantly firing back and forth. You can picture it like a three-person team, right? And each team member has a unique and absolutely vital role. If any one of them stops talking, the whole operation is at risk.
All right, so let's break down these three essential conversations. We're going to look at what they're saying, how they're saying it, and crucially, why they all need their own separate lines.
So check this out. First up, you've got the manual control link. This is the uplink on the 2.4 gigahertz band, and it's basically the pilot shouting commands up to the drone. Then you've got the telemetry downlink on a totally different, lower frequency. That's the drone talking back, reporting its status, position, speed, altitude. And finally, you have the video feed, sending that live picture down to the ground, often on yet another band like 5.8 gigahertz, just to make sure the signals don't get their wires crossed.
Now, this traditional three-part system, it works, sure, but man, it is far from perfect. That telemetry link, it has barely enough bandwidth to send the most basic data. Forget about anything fancy. The video is usually a fuzzy, low-res analog signal. And here's the big one. Each of these systems needs its own separate piece of hardware. So you've got these three totally independent radio systems just kind of bolted onto one small aircraft. And yeah, that creates a pretty big problem. It's clunky, it's inefficient, and it opens up a whole new can of worms for drone builders and pilots. And this quote right here, it just nails it. You end up with, well, a mess. All those separate parts mean more wires, more weight for the drone to lug around, and more power getting sucked from the battery. And even worse, you have three different radios all blasting out signals that can interfere with each other, which, believe me, is a constant headache. In the old system, this hardware mess was just the reality of it. You had a dedicated radio receiver for control, a whole other radio for telemetry, a separate video transmitter, and if you wanted to actually see that video on a laptop, you needed yet another piece of gear, a USB capture device. It was a lot to juggle. Okay, so with all this information flying around, commands going up, data coming down, what's actually processing it all to create stable flight? Who's the pilot inside the drone? And that, my friends, brings us to the hero of our story, the flight controller. This little circuit board is the central nervous system. It is the brain of the whole operation, and it's the thing responsible for making sense of all that chaos. The flight controller is plugged into literally everything. It takes the commands from the pilot's receiver, it reads all the data from the onboard sensors, and then it makes thousands of calculations every single second to tell the motors exactly how fast to spin to keep that drone perfectly stable and moving exactly where you want it to go. Now, to do its job, this little brain has its own set of incredible senses. The gyroscope is telling it if it's tilting or turning. The accelerometer is sensing its movement and orientation. The barometer is measuring air pressure to figure out its altitude. And the magnetometer acts just like a digital compass. It's getting a constant flood of data from all these sources at once. So it all comes down to this relentless, high-speed feedback loop. The controller gets a command, right? Like, move forward. It then immediately reads the sensors to see what the drone is actually doing. It calculates the difference between those two things and instantly sends updated commands to the motors to correct everything and execute the maneuver. This whole process happens hundreds of times every single second. It's wild. Okay, now let's circle back to that messy three-part communication system we were talking about. A few years ago, some smart engineers looked at that tangle of wires and radios and asked a very simple question that was going to change everything. And the question was so simple, but it was a total game changer. Why are we juggling three separate, inefficient systems when modern technology could just combine them into one? DJI really pioneered this with their Lightbridge system, creating a single powerful digital link that could handle the whole shebang. And this comparison just illustrates the change so perfectly. You take that whole laundry list of separate components from the old way, and you replace all of it with a single compact module on the drone. That's it. One piece of hardware doing the job of four.
And the result? It's just elegant. One module on the drone handles control, telemetry, and video. And on the ground, one matching module plugs right into your computer or tablet, and boom, all that data just appears seamlessly in one single app.
And the benefits? Oh, they are massive. You get crystal clear, high-def video instead of that old fuzzy stuff. The drone is lighter and way more power efficient. And with fewer components and cables, there's a much lower risk of interference or something just failing. It fundamentally makes drones more reliable, way more powerful, and a whole lot easier to use. This evolution, this journey from a tangle of signals to one clear, powerful link is really what has enabled so much of the modern drone revolution. And it kind of leaves you with one final thought. What becomes possible when a drone's communication is no longer a frustrating limitation, but one of its most powerful features?